Thanks for joining us for this exclusive rebroadcast of our free CE event brought to you by Dentsply Atlantis and RDL. You can find out about this and other events through our website at www.rdl-usa.com. We offer lots of these events, and there are several more to come in 2015. You can also sign up for our newsletter on our website to have updates about this and other free CE events delivered right to your inbox. Just click on the Contact Us page and fill out the form. If you missed the live event, you unfortunately missed the free CE credits, but there's still lots of good information here to learn about new and unique restorative option. We now join Gary Burton, Technical Advisor for Dentsply Atlantis, as he discusses the Conus Abutment. Thanks for watching.
We can produce them at a 0, 5, 10, 15, 20, 25, and 30 degree correction for angulation on it. They all have a 5-degree taper on them, so that gives us an extra about 10 degrees to play with beyond that 30 degrees. So we can handle almost the 40 degrees of divergency as far as a path of insertion is concerned with a restoration on this. The component that's processed into the denture is just basically it is a telescope coping. These are all prefabricated to fit on the abutment, so these are stock components here. I know one says a retentive cap, one says non-retentive cap. These are a gold alloy, about a 64-65% gold. The retentive cap, that simply refers to the undercuts or the retentive element on the outside of the coping for processing into the denture with acrylic or composite. The non-retentive component is used for either bonding the place or laser welding. It's still retentive internally where it presses the place onto the conus abutment. The nice thing about this restoration is that it gives you the option to go with a flange or without a flange. It is an implant supported restoration. Although the restoration will routinely sit on the tissue and rest on the tissue, which is fine since it's removable. It gives it hygiene capabilities since we can take the restoration down to the tissue and sometimes handle phonetic issues a little bit easier as compared to maybe like the hybrid case where we look at it, but it gives you the option to go either or with it, wherever works out best for the patient. It is retentive enough to handle that situation. You can go with or without a pallet on it. You can go with a partial pallet, whatever might be needed for that specific patient on the case. As far as the production or thought process in these cases, I tend to use it or think of it in design more like a fixed hybrid. What I mean by that is using the same principles that we'll use into a fixed hybrid, such as AP spread between the implants or the cantilever distance off the most distal implant. If you're asking for kind of an ideal number on that AP spread, we will probably say, give us 10 millimeters and we're in really good shape. Do we do them with less? Yes, we have. With more AP spread, of course, that's fine on it. The mass majority of these cases are done with 4 implants, and it does require 4 implants on the case because it is a very rigid type of restoration that you are dealing with, and it is an implant-supported case that we're working with on these cases. It's a few different shots, of capabilities of this. So we'll just kind of walk through what is the basic needs for doing one of these cases. Implants are going to be placed, however they're put in there, whether it is guided surgery or, however they're put in. We've got some implants in there that we're working with. We're going to do fixture level impressions on this case. Ideally, you're going to want to make sure that the restoration or the model is verified for accuracy. It can be processed in the laboratory, or you can do the processing at chairside on the case, whichever is going to work out best for you. Sometimes it ends up being a combination of the two, depending on how things fit or work out, and you have variables in impression materials and materials that you work with that the model could possibly be off. But it is recommended and highly recommended that the model is verified for accuracy on it. We're going to also have that model produced as a soft tissue model, because there's going to be a scan run on this case. So we want to then, once we get everything verified, we're going to go through the wax try-in process on the case. So we're going to get everything up to a wax try-in, just like we're doing an overdenture case on it. The laboratory will go into web order, and then they will fill out the information on the case. So what's needed is that master cast, making sure that the analogs are in good condition, soft tissue on it, diagnostic wax up, that web order ticket, and then it can be shipped off to Atlantis, and they'll run the scans on it. If the laboratory has a 3-shape scanner, they can do the scanning remotely at the laboratory themselves on the case. Now, what's going to happen once it gets there and they run the scans on it is someone there is going to design the positioning of these abutments on it. And pictures are going to go back to the laboratory. They're not going to make the abutments yet. They're going to send pictures to the lab that the lab and the doctor can view and look at the positioning of the abutments, the height of the abutments, make sure that as everything is where you want it to be. Within that software, the laboratory or you can go into a 3D editor and start moving these abutments around and making changes to them. Once you get them like you want them and you approve it, then they will mill the abutments and ship them out. It takes them 1 day to mill the abutments. That's it. So once they get all the information in, they'll mill the abutments and then ship them back out overnight to the cases, to the laboratory. Little bit of information on what's actually happening in the decision making when they're first designing these abutments. What's going to happen is one of these abutments in here is going to become a common denominator, and all the other abutments are going to follow the path of that abutment that's chosen to be the common denominator between all of them. Usually the abutment that is the most angled becomes the common denominator, because the more the angle, the abutment becomes a little bit taller. And what they'll do is they will, within the pictures that you get, all of the abutments will be lined up to the same path of insertion, and they'll all be the same height. Exactly. But within the software, you can adjust the height of them. They don't all have to be the same height. For me, I like to get as much room as I can get for space for the restoration that's going to be on top of this. So, stay as strong as possible. Now, routinely within these restorations, they will be reinforced with some type of maybe titanium mesh or a low-cost cast frame. I'll show you a picture of one at the end of it. There'll be a couple of pictures, and sometimes we do a full partial type of frame within the restoration. The copings here are also visible as an overlay within the software, so you can see exactly where those copings are setting on top of those abutments. So what you'll usually notice is if you have an implant that's pretty much straight up and down, this space from here down to the margin on the abutment will be much greater than an angled one, where that space would become tighter between here and say the margin of the abutment itself. So you can say, well, okay, I can shorten that down and get me some more intercrucial space on this. Just for information to show you how the copings kind of fit the place, when the coping's seated down, there'll actually be a space between the top of the abutment and the inside top the coping, and that space is right at 3/4 of a millimeter. Then it'll seat down. When these are routinely made, the margins on the abutment will routinely be super gingival. And then the margin of the coping will set higher than the margin of the abutment. The copings from here to here, they're all 5 millimeters tall. So from the implant to the top of the coping, once it's seated on the abutment, that height, overall height, is right about 6.5 to maybe 7 millimeters. It kind of depends on the implant system that it's made for. As the abutment angles, if it's angled, it does become a little bit taller. So it could increase in height about 1.5 millimeters. So it does require a little bit of height for these cases. An ideal height, if I knew nothing about a case, I would say give me 11 millimeters of space, and I can pretty much handle just about anything on it. Did have a case where we only had 8 millimeters of space. We did this one in beta testing, and we knew that the space was going to be really tight, so we did the case as guided and had all the implants placed really straight up and down. And some of these information things we learned in beta testing, but one of the things at the time was we were routinely getting our abutments, as I said, all the margins being super gingival. So we called up to Atlantis and asked, hey, can you put the margin of the abutment subgingival and still leave the margin on the coping super gingival? And they said, yeah, we can do that. So by doing that and making those adjustments, we were able to gain a little bit more interocclusal space. So we were able to do a case where we only had 8 millimeters of interocclusal space. So you can adjust things and work with it to get some of the things you might need in a particular case. So this kind of gives you an idea of a cutaway on the coping on top of an abutment, what it kind of looks like on the case. This is a case that we did in beta, and I actually came across a lot of information in this case, but a little bit of history on it. The doctor that did this in Houston is Ron Hickerson, and he called me up, said the patient, they put in 7 implants originally, and the patient was just terrible with hygiene. They had nothing at all on the case, just an overdenture relined over some healing abutments, and they lost 1 implant. And you see they got some bone loss on this one, a little bit of bone loss on this one. I think there was a little bit over here on this one. And he just said, we can't do a fixed hybrid on this. It won't work. Patient, just bad with hygiene. So told him about these particular type of abutments, and he said, well, let's just go ahead and do it. So this is what we did on the case to verify the model is we put the open trim pressure post in the patient's mouth, and then linked everything together with some floss, and then he used GC pattern resin to bridge everything together. And then we unscrewed them all, pulled this entire piece out of the mouth, sectioned it between each implant, and put it back in the mouth, and then tacked it back together in the patient's mouth. And then that was done to try to take any distortion out of the material. And so at that point, we went in and took impressions on the case. So this on the cases, we were just, getting the abutments back. We were in beta. And of course, here you can see we had quite a bit of angle here, here, a little bit here and here, and this was pretty much straight up and down on the case. We had to have a couple of positioning jigs to put this into place. So we had a positioning jig made. The lab actually made it all in one piece, and we got it back and just cut it in the middle, and then keyed this to this, and here to here, got everything in. And this was the restoration that was produced for the case on it. But one of the things that cropped up at the time was truthfully, we weren't exactly sure how to make sure it fit okay on it, because we knew PIP wasn't going to work because of the spacing between the copings. We weren't sure what to look for on it. And so we figured, well, let's put it to place and shoot an x-ray and try to look at the axial walls. We couldn't check margins because your margins don't line up together. Your margin of the coping is going to always be higher than the margin on the abutment itself. And looking at the x-rays, we weren't sure. So what we decided to do in the case was we took all of these abutments out here and put the restoration down on one abutment and then checked the occlusion, checked how it fit, kind of talked to the patient to see how it felt on the tissue, checked the tissue, looked okay. Then we slowly added one abutment at a time around the arch, checking it to see if it fit the same way on it. When we got to the fifth abutment, we could easily see it wasn't going down the same way as it did with the first four on it. So then we took that abutment out, put it in the sixth one, same thing. It wasn't going down in place. So all we did was we took the overdenture and we cut these two copings out and then picked those two up at chair side, so you can actually see the difference in the material colors there on those two. And everything went to place just fine at that point. So this case has done really good. The patient's done well with it. Hygiene's done good, and no issues up to this point. And it's been in for a good while now on the case. So just another shot of that in the patient's mouth. We've also done some of these cases where we produced the restoration and picked it up at chair side on it. But before we kind of go into that, I just want to go to a couple of things that I've kind of come across in working with these cases, and a couple of the scenarios that we've come across as far as being an issue. And I just want to clarify this. I'll talk about issues. I'm kind of the guy that gets all the calls on whatever issues that might come across. So it may seem like we've had issues, but as an overall whole, it's done really well. But there has been a couple of things that's come up. One of them has been sometimes they're too retentive on the cases. And this is a little bit anecdotal, but one thing that I've noticed in retention levels on these things is when this AP spread became very tight, so the AP spread is just simply drawing a line through here, measure that distance. That gives us the AP spread on it. When it became too tight, it seemed that we kind of lost a little bit of AP or retention. I think it's just the way things seated down to place. And as the spread expanded out a little bit on it, retention became a little bit better, it seemed, on the cases. But if the retention was too tight on this for the patient, the initial things that we would try was, teaching the patient, this is where the implants are. This is where you have to grab the denture and pull. Try to locate them in either a central position or grabbing directly over the implants and showing them the right path of insertion to pull on it. If that was difficult for them, then we would create a notch into the restoration so they knew where to grab at on the case. If that wasn't working, then we kind of went to this point on it. It was too retentive. You can see our axial walls here, and the coping seat over top of that. So here's where the screw access hole is on these, you can see easily. So what we would do is actually go in and start reducing or taking away some of this access hole, cutting this abutment away down here more along the axial wall and around this area. So we might widen that hole out just a little bit, and that took contact away from the coping that was creating a retention, so it dropped the retention down in the case. And this is a little bit arbitrary. It's almost kind of like do a little here, back and forth until the patient was comfortable. And that tended to work really well on the case. Now, on the other far side of that is there was a couple of cases, patients or cases that there was not enough retention. And one thing that we tried to look at on this, what we noticed is as angles become greater, because of this access hole, we lost more of the axial wall on the abutment. So when we had a number of implants with a great bit of angles on it, we became aware that our retention levels might drop down some. So within the software, we would look at it and try to make sure to adjust our abutments a little bit by tilting them and watching this axial wall drop or raise to see if we could create some more retention or make sure we're getting the retention in the cases. It is one thing to be aware of on cases with maybe 4 implants that the surgeon's looking at going, I've got a lot of different angles here. It might be a scenario that they decide they may want a 5th implant in there. It doesn't happen very often, but it's just something to be aware of on the cases. Just kind of wanted to go over that. So in doing a chairside pickup, this is another case that Arnie Rosen did. He's a prosthodontist in Boston area. So he's got all his abutments in place, put the copings in, tried the denture in to make sure everything's fit okay. So when he puts these copings on, what he's doing is he's doing 2 at a time here and leaving these without the copings, but you want to block these things out. Now Arnie, when he does the block out on it here, you can see he put the block out pieces all the way down. You can use whatever you want for block out. But routinely in the processing, this area of the coping right here will not have acrylic processed against it. So the area below the retentive element in it stays clear of acrylic on the case. So then you'll put the denture down and relieve the denture where you can access through the top of it, seat the denture to place, make sure the occlusions, everything's good, you can access it all. And then he'll routinely go in and put some acrylic all over these housings, dab it around. We'll take the denture out, dab acrylic all around the housings, and then seat it back in place, and then he will go ahead and fill that void with acrylic on the 2 sites, the most posterior ones. Pull it, make sure that's good, and then do the next 2 or whatever else is left in the site. So once he gets 2 of them down to place, usually he'll start with the most posterior ones on it, get those 2 to place, and then do the anterior ones. He did it this way, then he came back, and then he filled the void a little bit around that to cover things up. I've helped out with, I think, about 4 or 5 cases now where we've done chairside pickup, and we do it pretty much the same exact way, and they work really well. The main thing is just making sure that the patient's got it in occlusion and the occlusion's right on it. Don't over-compress it. Retention, the amount of retention can somewhat be controlled with these things by how much pressure the copings are pushed down with. So the more they push on it, the more retentive it's going to be. Don't have any actual, and there are no true actual numbers on the amount of retention per site because it depends on how much pressure is put on that coping to create retention. But Scott Douglas at the VA in San Antonio did some of his own pull-off tests there, and he was getting as high as 20 pounds per site for retention on it. So they're pretty retentive, and they will become more retentive through function, especially the first couple of weeks on the cases. So they hold up really well, get good retention on the case, and this is actually just a temporary that he was doing on this one to show the process on it. Done some partially edentulous cases with these, and they've worked out really well. We've been really specific with them, picky about who we've done them with. So just a couple of shots of this particular patient. You can see it's a genetic defect here, but still a little bit of problem with hygiene. So they went in, placed some implants on the case, did some crowns. There's the abutments that are made, did some veneers on it, some crowns on the patient, corrected the path of insertion from the placement of the implants on there, and then the restoration, that's what she did have. That's what she has now. So, it's retentive enough with the 3 implants that no clasping is needed. She can take this out when it's needed, take it out at night, clean up around it, put it in some cleaning solution, and then we'll put a night guard in where we'll produce a night guard that simply slides to place over the copings themselves. So we'll try to get these dentures completely out of the patient's mouth at night, so if they have any parafunctional habits, they aren't tearing up the denture or working on it. We can make a night guard for them. And we've done those a couple different ways. When we first initially started doing these night guards, we were doing them with the copings, the gold copings in them. And those gold copings, they are expensive. I mean, they're about $90 a piece. So these night guards, they became expensive, and so we tried to start looking for a way to make them a little bit less expensive on it. So what we did was we took the copings into the laboratory and scanned them and then milled them out of PMMA. And then we started using some PMMA copings in place of the gold copings for the night guards, which reduced the cost, tremendously on the case. We figured worst case scenario, if we need one gold coping in there, we'll put one gold coping in, whatever is needed. And then actually we started kind of trying to work this where we could make it even less expensive and a little bit quicker to deal with. Had a case where a surgeon called up and he was wanting to produce a night guard real quick for a patient who was going out of the country. And so I was sitting there trying to tell him how to do this with a duplicating flask, and then I kind of thought for a second. I said, well, when's the patient going out of the country? And he goes, well, in about 2 weeks. And so I just thought, well, why don't you see if you can get the patient to come over to a lab. And so what we did, he said, yeah, that's fine. So we got him in the lab. We actually just took the restoration itself and scanned it and then milled the whole restoration out of PMMA. And then within the software, we just changed the occlusion on it. And we made, a very low cost effective night guard by doing that on the case. So, we figure out ways to get around it and reduce the cost as best we could, and it's worked really well so far. Sorry, I had to get a drink. And here's another case that we did 3 implants again on it. Nope, I'll hit backwards, sorry. Look familiar. Right here's another case. 3 implants are placed. You can kind of see the defect in the bone right here in this area. This one was actually pretty good. But implants were put in, of course, and then the abutments are made for the case here. And then what we ended up doing on this case was this is a pink composite on it. We made kind of a full frame for this, but fired porcelain to it. So this is ceramics on here with some, and then they needed a little bit of palette on this case because of the defect that was there in that area. So that one worked out really good too. Partially edentulous cases that I've dealt with personally with less than 3 implants. Do a 3-unit bridge. It's not the implants holding up I'm worried about, because we do a fixed restoration on that and it should be fine. I'm not sure how it would be retentive wise on that type of case. I just don't know about that one. Well, we've only done it with some 3-unit cases and they've worked well on this. We can make these abutments for numerous different implant systems. All of the implants that Atlantis produces abutments for, they can make Conus abutments for. The only ones that they can't do them for, I should say, is the external hexed implants. They just don't produce them for the external hexed implants at this time. This kind of gives you a view of possibly, this is almost routine of what the frames will look like to reinforce these restorations. Kind of a low-cost cast frame in place, you know, and haven't come really realistically across too many issues. I think I really covered what issues that we tend to have on these cases, and it's been fairly straightforward. I will tell you this, most of the cases have been for implant cases, the mass majority of them.
Hey, Gary, you cut out just a little bit. Could you repeat that last sentence? The vast majority of the cases you've seen have been for implants.
Yeah, 4 or 5 implants. The mass majority that I worked on have been 4. We've implant cases originally going to be Conus cases. They were originally going to be high to move them to Conus. We knew that those cases were going to be really, you know, highly retentive, and it might be an issue. So what we did on those cases ahead of time was, on 1 or 2 of the implants in them, we actually used PMMA copings instead of gold copings in a couple of the sites, because we knew we could always come back and put in gold copings on this. Couple things that might help. Some of these situations we've had to cut these copings out for maybe like the very first case I showed you. Those first cases, we took a burr, we just kind of started working around the coping till we got it out of there on it. It was a little bit time consuming. It wasn't that hard to do, but time consuming. One of the things that I've kind of come across doing, you know, kind of going back to working with locators and removing those housings out of, like the little amalgamous has kind of the ball on the end of it. And what we would do was heat it up over the Bunsen burner, get it really hot, and then place it into the coping and let that heat coping out. So that worked pretty good. So if that's helpful in getting those copings out, if you have to do a reprocess.
Okay, Gary, we do have one question from an audience member.
The other nice things about these cases. Yes.
No, go ahead, please.
Yeah. Oh, okay, go ahead.
One of the questions that we have from an audience member is, what is the best way to obtain the vertical on
the go ahead with the question.
Is it, well, how best obtain vertical on an edentulous patient? In other words, or a better question might be, how do you evaluate maybe an existing edentulous patient for how much vertical they already have? Do you have any tips for them to evaluate, you know, existing denture cases?
Look at them. We're going to take measurements, and we're going to measure and see what they if we don't have that information, then what we're going to probably have to do at that point is go up. You can't or the all-on-4 type of situation. On the cases and you know, working with them. But you know, it's pretty straightforward. Either, like I said, it's either we're going to take measurements with existing dentition, or we're going to have to go in with some wax try-ins and see what we can, you know, get the patient comfortably in, and then make a decision at that point. We don't have to put implants in at that time. We can go, you know, if they're totally edentulous and we have to go in and redo a new wax setup on them and work them, you know, work from that standpoint. And That's usually what we'll look at on the case and doing that.
Okay.
Does that answer your question okay for you? Or
I think that answers the question pretty well. I'd like to go ahead and address a couple of the other questions that we've received.
Okay.
All right, with you. One of the questions that we had is, with a full pallet, do you need a metal framework? And I think for the type of restoration that we're talking about here, although we probably would not do a full pallet on these cases, I don't think, Gary, you can chime in here. You haven't done a full pallet, but you've done partial pallets on these cases, correct?
We've done partial pallets on it. We have not done full pallets on it. We haven't routinely needed a full pallet because the retention has been good enough. And the other thing, if retention isn't enough, I mean, on a case, we can go back and we can do remills on these abutments. Remember, these are Conus abutments, okay? Or these Conus abutments are Atlantis abutments. So what that means is they are warranted for the life of the patient, okay? So if something's wrong with it, they're going to remill it at no charge. Or if something goes bad or it goes south down the road, say it's an all-on-4 case, okay, and they lose an implant. We can go back and we can put another implant in, do an impression of that existing or that new implant fixture level, and pick up the existing copings at abutment level, make a model, shoot that off to Atlantis, and then they can mill another abutment to line up with those existing abutments. Put it in the patient's mouth, take the restoration that we have at hand. We don't have to change the restoration to make a new one, and then pick up that coping and get it chair side. So, we can salvage the cases if something goes wrong down there.
That's good information, Gary. The rest of that question is, do we always do a metal framework? And the answer is no, you don't. Sorry, go ahead.
Oh, well, what I was going to say is we have routinely and have recommended some type of reinforcement within the restoration because, you're going to have sometimes some cantilever effect on it, and these patients, they can eat and function just like they have a fixed hybrid in there. So some types of reinforcement. Now, to answer your question, no, we haven't always done a metal frame in them or reinforced. I think you just have to evaluate the patient at hand. I had a couple of patients that I've helped with that, they were in their early 80s opposing a denture. We just used the existing denture. Said, go for it. Big deal. Worst case scenario, the denture breaks, we make a new one. So I haven't personally dealt with any of the cases that have used the fiber meshes, although I have talked to some laboratories that have done them and said they're holding up okay so far on it. So that might be, I think it's just evaluating the patient is what it is on it.
Okay, Gary, and one of the last questions that we received is, do you believe that the Conus abutment is a full-fledged replacement for like screw-retained hybrids, or do you see it more as an alternative to or something in the package?
Well, I think that it can be a full-fledged replacement to a fixed hybrid because it gives them the same function capabilities as a fixed hybrid. If the patient wants something they can't take out of their mouth, then no, it's not going to work for them. Some patients, I want something in my mouth and I can't take it out. What I can tell you is this: I don't know if any of y'all are familiar with like Mike Block, oral surgeon down in New Orleans. He's been in implants since the 80s. We were down there doing some seminars for him with his referral groups. Mike Block told everybody his number one restoration now at this time for some type of hybrid or a dentulous patient is Conus over a fixed hybrid. So in his eyes, it's a replacement. He goes, I'll do whatever the patient wants or what you want, but he goes, this is my number one choice And, he gave his reasons, and his reasons was, I see a lot of hygiene issues with fixed hybrids, whereas this, we can control the hygiene problems on the cases,
So if I may weigh in, and I certainly don't have the experience with Conus that you do, Gary, but from a laboratory or from RDL's perspective, we see the Conus Abutment as a tremendous alternative available to us if needed. The hybrid, when you use a hybrid is a delicate discussion. If surgery has been done specifically to develop the patient and develop the vertical dimension for a hybrid restoration, then the hygiene issues and things that you see from a lot of hybrid cases shouldn't be an issue. However, if the patient has other circumstances, if implants were placed without bone reduction or without significant bone reduction, if you have other scenarios, or if the patient actually wants something removable, I would see the Conus Abutment as a step up from, say, for example, the locator overdenture. But there are different requirements for each of those three types of restorations. But it would be a significant step up from a locator.
Yeah, and I mean, you can talk with them about pricing on this, and it is what I can tell you as an average, this compared to a fixed hybrid to a patient as a overall fee, including 4 implants, it is usually in the area of about $10,000 less as an average across the country. Okay, so there's some quite a bit of difference in there. Yes, it's going to be more expensive than a locator or a ball, something like that, of course, on the cases. But everything is, and don't get me, I don't want people to get me wrong. I'm not sitting here saying, here's this, you got to use this for everything. It's another option. That's
right.
What it is.
And that's really what our job in the dental world is, to be able to provide the options to you as the clinicians to make sure that we can support whatever scenario comes up with your patients, because we all know that you really can't just drop patients into one category and another. But we are happy to be able to offer this type of restoration and be able to meet specific patient needs with this type of restoration.
Yeah. There's a question here that someone's asking about if the patient can't get it out of their mouth or they can't remove it. Realistically, there are no special instruments for it. What we'll usually have to do is we're going to have to go in and we'll get it out. And there has been some cases that we, was in there really tight, and we had to get a crown remover on each side and pop it out and then start adjusting those abutments to where the patient could get it out. Now, for the upper, there was actually an engineer over in Florida that has these in his mouth in the upper, and he actually made a removal device that it's plastic. It's a hard plastic. It has kind of like a fork clips on it with a flat bottom that it locks into the top of his denture, and then just goes under his chin, and he opens his mouth, and it pulls the denture out. So if anybody ever needs one or needs to see a picture of one, I can give you the guy's phone number. He's an engineer, and he makes them and sells them out there. So that's the only instrument that's been made to remove it. But like I said, pretty much we do, if the patient can't get them out or they're having trouble, we have to go in and kind of start making some adjustments to the abutments on the case to make it where they can get it out. Okay. That might not be the answer that you want to hear, but that's that's pretty much the way it is.
That's certainly fun. It's always nice when patients get actively involved in finding something like that, as long as they don't damage appliances.
Yeah.
Right?
Yeah. It was an interesting story because the patient asked the surgeon, goes, "Is there anything for removing this?" And the surgeon told him, he goes, "No, there isn't." But I don't know if the surgeon was serious or joking around, but the surgeon told me the story, and he said, because I just said to him, "You're an engineer, make something." So he goes, next time he showed up at the office, he had a device. to do it with on there. So that was pretty interesting. One thing that I would like to mention on here is that, you know, one of the big questions get on there is how much of a distal extension can we do on these? And like I said, I use the same principles as a fixed hybrid on it. But I will tell you this, on all of the 4-unit cases, beyond or at the most distal implant, basically, in the cases I've had any say-so in, we've done no more than a bicuspid molar on the distal extension. I'm not saying you can't do more. I'm just saying that's what, you know, we've done and said I'm comfortable with, and it's had no problems at that point so far. Okay. I don't know if that's helpful, but just kind of throwing that out there.
No, it's good. It's good information, Gary.
Okay. Any other questions y'all have or can think of? I mean, it's pretty straightforward. But anything else you can think of? Or did I miss something on here? No.
Well, Gary, I truly appreciate your time, and really appreciate all of our attendees showing up today. Very good turnout for this. We will be making this session available as a recorded version that you can feel free to share with your colleagues. It'll be available on our website. We'll also be sending out an email to those of you who registered today. And I'd also like to invite you to keep a watch out in both your email and on our website for upcoming other CE events that we've got coming up. Some have actual CE credit, and some, you know, we're trying to get that, but either way, we've got lots of good educational events coming up in the next couple of months. So please, if you enjoyed today, make sure and tell someone about it and pass them emails and information along to your colleagues. Unless anybody else has any additional questions, then we'll probably go ahead and call this a day. Gary, I really appreciate your time and effort on this. It's been a pleasure working with you.
Okay, thanks a lot. I'm more than happy to try to help out anytime.
All right, thank you very much.